Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we just started as a polynuclear and heteronuclear aromatic compound. And we are discussing the introduction regarding that chapter number first, polynuclear and the heteronuclear aromatic compound. In what do you mean by the polynuclear and what do you mean by the heteronuclear aromatic compound? So here polynuclear is nothing but as a polycyclic aromatic compound, specially they have mentioned over here. And therefore, if you remember polycyclic aromatic compound, it is belonging to hydrocarbons, or we can say it is a homocyclic. It means that the cycle which is made by the same carbon atom, and therefore it is termed as a homocyclic. And polycyclic, that polycyclic is nothing but as a polynuclear, when the same atom, especially we are discussing the organic chemistry, and as you all know, organic chemistry means what? The study of compound that contains carbon atom. The reason behind it also you know that because only the carbon atom has one unique property. The name of that unique property is a catenation. Catenation meaning to form the chain. So due to this catenation property of that carbon atom, there are millions of organic compounds, trillions of organic compounds are known, and thousands of organic compounds are daily synthesized in the research laboratories, that we already know that. And here the polycyclic and especially we are discussing as a aromatic compound. The simplest aromatic compound is a benzene. Why benzene is called as a aromatic compound? Because for aromatic compound there are certain criteria. Those organic compound fulfilling those criteria, essentially that type of the compounds are generally termed as a aromatic compound, and benzene is one of the simplest aromatic compound, and that's why that kind of the, but here specifically polynuclear. So here you just referred polynuclear is nothing but as a polycyclic compound which is made by the same atom. Generally here in this case is a carbon atom, and simplest example is a benzene. As I already told you that benzene is aromatic in nature because it fulfilling all the criteria which is required for aromatic compound. The criteria are like this. First one, the compound must be cyclic in nature. Number two, the compound must be planar. Number three, the double bond must be in conjugation and fulfilling that obeys the Hooke's rule, and Hooke's rule, as we know that 4n plus 2 pi electron, and those are obeying that electron, then and then we can call it as a aromatic compound. This is a theoretical way to determine or to measure the aromaticity of organic compound, or you can identify the aromaticity of the organic compound. But you all know, when you are performing the organic experiment, especially organic qualitative analysis. Organic qualitative analysis, generally the experiments are classified or divided into two types. One is called as a qualitative analysis and another one is called as a quantitative analysis. Quantitative analysis means the question start from how much, and qualitative means question start from what are the elements present in the given sample, which is generally termed as a qualitative analysis. And quantitative analysis means what? How much amount of the sample present, how much amount of the sample present in the given mixture. So that is called as a quantitative. You are finding quantitatively exact amount of the substance present in the given mixture, or what we can call it as in the sample, you can say. Here, for example, you are performing as a titration, gravimetric analysis sometime, or some preparations are there in the organic chemistry experiment. So here you are generally finding exact amount, how much yield you are starting with the this much amount of the substance, and at the end you are getting the this much amount of the product, but exact quantity you are determining. You are taking as a here the exact quantity, mole to mole ratio, or W to W weight to weight ratio of the substrate and the reagent together, and ending product you are easily finding its yield. So, but in this case, but there is another method. So in a qualitative analysis, you are finding the what are the elements are present in the given sample, that is called as a qualitative analysis. So during performing the qualitative analysis in organic chemistry, there is one test to identify whether the given compound is aromatic in nature or aliphatic in nature. Very simple test. Whatever the sample you are getting, you take that substance, pinch of the substance on a wire gauze, or what we can call it on a copper gauze, put on a burner. If sooty flame comes, then your conclusion says that the given compound is aromatic in nature. If after burning, if non-sooty flame comes, your conclusion, your observation, or your inference, you are saying the given compound is aliphatic in nature. So this is one of the simplest method to determine or to identify whether the given compound is aromatic in nature or aliphatic in nature. So that's the here. But theoretically, just now I mentioned that how do you find out the given organic compound is aromatic in nature or not. So that is aromatic hydrocarbons are there. One is a benzene, is the simplest one, and as we know that the benzene there, before considering the structure of the benzene, because we are discussing as an introduction, and there we are discussing about that homocyclic means the cycles are made up of by only same carbon atom. Generally here is a carbon atom, and that's why we are calling it a homocyclic or polycyclic. Homocyclic or polycyclic, poly means many cycles come together and form as a compound, that we can call it as a polycyclic or polynuclear. And as I already told you, one of the simplest aromatic compound is a benzene. Benzene fulfilling the criteria which I have already just mentioned. It must be planar, conjugated and cyclic in nature and obeys the 4n plus 2 pi electron, are known as aromatic compound, and benzene fulfilling these all necessary criteria. Essentially, there is a nomenclature system. Have you heard about this? Before considering the structure of the benzene, we will discuss the nomenclature system. And nomenclature system, nomenclature means what? The systematic way of giving the name of the organic compound which are synthesized in the different laboratories are known as a nomenclature system. And generally there are two systems in use for nomenclature. One is called as a common name and another one is called as a IUPAC name. Common name or the travel name, some of the compound are known by their common names. Those are the simplest compound are there. It can be possible to remember that compounds, the name of that compounds, but in a complex molecule it is very difficult to remember the common name of that compound, and therefore there is a committee formulated globally, and they have given certain rules, and according to that rule, by following that rule, we can easily find out the correct IUPAC, correct name of that organic compound. And that system I just told you that IUPAC, the full form of that IUPAC is the International Union of Pure and Applied Chemistry. And there benzene, we know that it has a molecular formula C6H6, as we know that. And but the structure of that benzene is a puzzled organic chemist that we will see later on. But before that, let us see the monosubstituted benzene, how to give the name of that. For example, one of the hydrogen atom replaced by chlorine and the resulting compound formed is called as a chlorobenzene. While naming such compound, whatever substituent present on that benzene, you first take the name of the substituent followed by the word benzene. Just remember, here one is a chlorine or bromine or iodine, then you can call it as iodobenzene, bromobenzene. And some of the monosubstituted benzene are they known by their common names. For example, one of the hydrogen atom get replaced by hydroxy group, the common name of that compound is a phenol. Another molecule, hydrogen atom replaced by NH2, then that the common name of that compound is aniline. One of the hydrogen atom get replaced by OCS3. The common name of that compound is known as anisole. The one of the hydrogen atom get replaced by COOH, then we can call it as a benzoic acid, benzaldehyde, cumene, toluene, benzyl chloride. These are the some of the mono substituted benzene has a special name and they are known by their common names. Suppose now when the mono substituted benzene is there are hydrogen atom, rest of the 5 hydrogen atom, they are non-equivalent in nature. In a benzene, all the 6 hydrogen atom are the equivalent in nature, and therefore by replacing one of them we are getting as a resulting compound is a monosubstituted. But that monosubstituted benzene, whatever the remaining hydrogen in the benzene, they are not the identical, they are non-equivalent in nature. So how many type of the hydrogen atom we can say or proton? There are generally 3 non-equivalent protons are present on monosubstituted benzene. 2 are the ortho, 2 are the meta, and 2 are the 1 are the para position. So there are 3 different type of the compounds are present. Disubstituted derivative we can say over here. There are 3 possible isomeric compounds of disubstituted benzene derivatives, which are differentiated by the use of names ortho, meta and para as per their relative position or by numbering method. Let's see 2 identical substituents. Here disubstituted benzene. Here we can say disubstituted benzene derivatives, you can say derivatives, disubstituted benzene derivatives. Here two identical substituents. Two identical substituent. For example, say here, this is one of the compound. Here I am putting Cl. Here also has a Cl. Let us see here is a Br. I am putting here another Br. Here I shown the compound here. Let us see I. Here also has a I. Anyway, you can see here. Here is a chlorine. Here you can write Br. Here also as a it may be as a Br here, or you can say you can draw anywhere structure here iodine. After that, you can say here iodine. So, or you can write here, this is the compound Cl, here is a Cl like this. Or you can write the compound this way, here Br, here also as a Br. Here you can write iodine here and one iodine at this position. Now, if you remember, this is a structure which I am writing over here. This is a X substituent. Let's say this is X substituent. It's a mono substituted, right? After the substitution, look at these two hydrogen atoms, these two positions with respect to, relative to this X, we can designate as O means ortho. O means ortho. Both are same side. Here, these two again, the same side, identical, and therefore we can call it as a meta. And exactly opposite, it is known as a para. So this is a meta, this is a para position. So if disubstituted are there, you can say like this. So this is a, if you consider this chlorine as a main substituent and this is another identical substituent, where it is present at ortho position, and therefore you can call it as a ortho dichlorobenzene. You can call it as a ortho dichlorobenzene. Ortho dichlorobenzene. This is ortho dichlorobenzene. Ortho dichlorobenzene, or you can use the numbering system. Numbering system, as we know that here the main substituent both are identical. You can start from here 1, 2, 3, 4, 5 and 6. Clockwise direction you can start the numbering. If you start from here, if you start counterclockwise manner the numbering, that is not the correct one. So here always remember, start the numbering in a such a way that the another substituent should get the lowest number. So that you have to keep in mind. So, or you can say here 1, 2, because at 1 and 2 position chlorine atom is present, and therefore you can call it as a dichlorobenzene. So that is there. Benzene, dichlorobenzene. Same way, here you can, now with respect to this chlorine, it is present at which position? Look at here. At 3 position. 3 position is generally termed as a meta position. 1, 2, 3, 4, 5 and 6. 6 carbon atom. So in a mono substituted you can give the number either this or that. At 3 and 5 position are termed as a meta. 2 and 6 are termed as ortho, and 4 position are generally referred as a para, right? Now this is present at meta, so you can call it as a meta dichlorobenzene. Here you can call it as a meta dichlorobenzene, or either this, or you can call it as a 1,3-dichlorobenzene. Look at here. Here 1, 2, 3, 4, and what is this position? The another chlorine atom present at the para position, and therefore you can call it as a para dichlorobenzene or 1,4-dichlorobenzene. So that are the name you can give here. So here, so now you are able to give the name of this compound. This bromine and this bromine, what they are at 1,3 position, means at meta position. So you can call it as a meta dibromo benzene, or you can say 1, 2, 3, 4, 5 and 6. So the bromine present at 1 and 3 position, dibromobenzene, you can say like this, meta dibromobenzene or 1,3 dibromobenzene. Essentially, look at here, both the bromine atom, they are present at 1, 2 position, or it is present at ortho position. So you can call it as a ortho dibromobenzene or 1, 2 dibromobenzene. And here these two are present at 1, 4 position. So you can call it as a 1, 4 dibromobenzene or para, or you can call it as a para dibromobenzene. Understood this one? Now moving toward the next one. Here look at this once again, this iodine present exactly opposite. So what is that position? That is a para position. So you can call it as a para diiodobenzene, para diiodobenzene, or you can say 1, 4 diiodobenzene, that would be the name of this compound. Now let us look at this structure carefully. These iodine, they are present at ortho position, and therefore you can call it as a ortho diiodobenzene or 1, 2 diiodobenzene. Now look at the third structure. Here the iodine, where it is present at meta position, and therefore we can call it as a meta diiodobenzene or 1, 3 diiodobenzene. So that is the way. But if different substituents are present, then how do you give the name of that compound? Start the numbering from the carbon to which main substituent is attached. Then proceed the numbering in a such a way that the substituted aromatic carbon should get the lowest number. So that is the another. If two different substituents are present, then how do you give the numbering system, or what you can call it as a, yes, if two different groups are present, let us say here one is a chlorine atom, one may be as a, here we can say iodine. So if such type of the compounds are there, then you can use as a numbering system 1, 2, 3, 4, 5 and 6. Then you can call it as a 1 chloro, 4 iodobenzene, 1 chloro 4 iodobenzene. Or suppose you have another structure, let's see here. This is one of the structure. Here NO2 group is present. Let's see, here is a chlorine atom I am mentioning. Now suppose this is the compound And if you are using here as a numbering system, which is the main substituent present in this structure, here nitro group, here is a chlorine, so nitro is a bigger, so you can say nitro group is a main substituent present on benzene moiety, therefore it should get the first one, this is the second, third, fourth, 5 and 6. So you can write as a 2-chloro nitrobenzene, 2-chloro-nitrobenzene. This is a name, or you can call it as a orthochloro, not ortho, orthochloro nitrobenzene. Now this is a way of giving the name of the compounds. I think there is some other compounds are there, and we can take number of examples here, and in the next lecture, in tomorrow's lecture, we will see the nomenclature system for polysubstitute, because there are 3 substituents are present in the aromatic compound. One we can call it as a monosubstitute, disubstitute and the polysubstitute. So how to give nomenclature system or name of that polysubstituted compound? Always out of the numbering system, how to give the name to that polysubstituted aromatic compound, that we will discuss in our next lecture. Till then, have a nice day. Thank you.